Section 8.5. Applying our debugging skills to a new problem. With our new skills in place and a new workflow, let's try tackling a more challenging debugging problem. Remember in Chapter 6 when we tried to determine the largest number of empty seats in a given row in a classroom? We're going to solve a similar problem here. Instead of looking for empty seats, let's say that we want to count the most students seated consecutively in a row because you're trying to space them out better before an exam. You could also imagine using this to space out people more if they want more personal space or if there's a pandemic. We wrote the prompt and a basic doc test, and Copilot generated a solution. The code appears in the following listing.
Listing 8.8. First attempt to count consecutive students in a row.
Given this chapter is about debugging, you can probably guess the code isn't working correctly. We caught this bug when we read the code Copilot gave us, but it's a subtle bug that we suspect could be missed fairly easily. If you see it already, great job. But pretend you didn't for the rest of the chapter. If you haven't seen it, the rest of the chapter is going to be more valuable to you. Let's imagine then that we just wrote this prompt and test case. We read through the code, and it looks like it's probably keeping track of the most consecutive students. As long as it sees a student in a seat, it increments the count. When there isn't a student in the seat, it checks to see whether the count is bigger than any previously seen and resets the count. It seems like it's at least on the right track. We included a test case, so we ran the code, and the test case passed. We're feeling pretty good about the code, but know we need to do more test cases, particularly ones to catch edge cases. Remember that edge cases are uncommon cases that could break the code. We know when we work with lists, it's good to check that the code does the right thing at the start and end of the list. To test the end of the list, let's add a test case where the largest group of consecutive students includes the last seat, and then rerun the code. Here's the new test case we're adding to the docstring.
See this code?
We run the code again and are surprised when the test cases fail. Here's what it told us. We reformatted the output for readability.
See this code?
That's odd. The code seemed to be working properly. Something about this edge case has uncovered the error. At this point, we'd want to generate some hypotheses about why the code isn't working properly to help guide our debugging efforts. If you're truly stumped, you could take the approach of just setting a breakpoint at the first line of code in the function and stepping through it rather than trying to create a hypothesis. Here are two hypotheses that come to mind. The updating of count is skipping the last element in the list. The updating of max count is missing the last element in the list. To simplify the debugging process, we removed the test that is passing, just set it aside to restore later, and are only going to run the test that is failing. The following listing shows our full code before we start the debugging process.
Listing 8.9. Code that will debug to count consecutive students.
We'll start with the first hypothesis. That count isn't updating properly at the end of the list, and set a breakpoint at the updating of count. Figure 8.12 shows the first time the debugger pauses after it started.
Figure 8.12. Debugger stopping before the first update of count.
From the debugger, we can see that count is still 0, so it hasn't been updated yet. We're in the first row of that first test case because row is S, empty space, SSSS. The seat we're looking at is an S, which is why the count is increasing. Let's click Continue in the debug toolbar to see the next update of count. The state of the debugger after clicking Continue appears in Figure 8.13.
Figure 8.13. Debugger stopping before the second update of count.
A fair bit has happened, it seems, since the last update of count because max count is now 1. This must have happened when the empty space was processed because max count was set to 1 and count was reset back to 0. At this point, we're at the third seat in the row with a student there, and count is ready to update. We'll want to check that count keeps updating with each new student. We clicked Continue, and count increased to 1. We clicked Continue again, and the count increased to 2. We click Continue once more, and the count increased to 3. At this point, we're at the last student in the row, and we want to check that count increases to 4. To check this, we clicked Step Over once, and count indeed updates to 4. You can see the state of the debugger at this point in Figure 8.14.
Figure 8.14. Debugger stopping right after the fourth consecutive update of count.
Well, we have good news and bad news at this point. The good news is that count is properly updating. The bad news is that our first hypothesis was wrong, and we haven't found our bug yet. We could move our breakpoint to the line where max count is updated, line 22. and then click Restart and start over the debugging process for our second hypothesis. But given that count is 4 right now in our debugger, let's just continue to trace through the code and make sure max count gets updated. Or rather, we know it won't be, so we want to see why. Before clicking Step Over, we've got a clue already present in the debugger. This clue comes from the fact that the next line of code to execute is for seat in row. But the student we just saw was the last student in row. This means this for loop is just about to finish, meaning we won't execute the body of the loop again, which means max count can't get updated. Let's see whether that's what happens by clicking Step Over. The state of the debugger appears in Figure 8.15.
Figure 8.15. Debugger stopping after finishing the first row.
We just finished processing the first row, but we never updated the max count. The next line of code will pick the next row, and the line after that will set count to 0 again. We finished the loop over the row without ever updating max count, even though we found a count that's bigger than the current max count. If you don't see the bug yet, we encourage you to step through until the next time max count is updated, and it may be more obvious at that point. The error in the code is that it only updates max count when it encounters an empty seat. This means that if a row ends with a student, the code to check whether max count should be updated will never run for that row. Examining the code more closely, the test to see whether max count should be updated and the update of max count should both occur either outside the if-else statement or right after count is updated. This is a fix we can probably just make manually because all we need to do is move 2 lines of code to a better location. The code in listing 8.10 is the corrected function, without the tests or prompts.
Listing 8.10. Corrected function to count consecutive students.
This new code does pass the test that failed with the old code and the original test. After adding another test that makes sure the code works when the longest group of consecutive students appears at the start of the row, we're more confident the code is now working properly.